A model small enough to run on a 3-year-old phone. No data center, no internet, no monthly bill. Just beat a reasoning model over 400 times its size. On the actual math benchmarks. That's not a typo, and it's not cherry-picked. And half the internet has already decided what it means. The cloud giants are the mainframes, and a swarm of tiny local models is the personal computer about to bury them. Data centers should be terrified. Here's the problem. The people actually running these models are quietly reporting something else. That in real use, the tiny ones are janky, wander off task, sometimes start replying in Chinese for no reason, and still quietly phone a big cloud model to get anything real done. So which is it? The most important shift in AI right now, or the most convincing benchmark illusion we've seen? The honest answer is neither, and it's more useful than both. Here's the map. What actually dropped? Why the benchmark is only half real? The one idea that makes it all click, and the stack you should actually build. Let's get into it. Start with what's real, because a lot of it is. Over the last stretch, a cluster of models under 2 billion parameters landed, and they are genuinely doing things models that small were not supposed to do. Exhibit 1. A 1.5 billion parameter model out of a Chinese lab, trained for a post-training budget of just $7,800, scored 80.3 on one of the hardest high school math Olympiad benchmarks. The reasoning model it beat on that test has over 400 times the parameters. Same story on 2 more math contests. The tiny model comes out ahead on all 3. And here's a fact check worth planting a flag on, because the breakout videos keep getting it wrong. They call this a 3 billion parameter model. It isn't. It's 1.5 billion, half the size they're giving it credit for, doing the thing anyway. Exhibit 2, and this is the one that matters most for what you'd actually use. Another lab shipped a 1 billion parameter model, 1.08 billion to be exact, with a 131,000 token context window, built-in tool calling, and the ability to run local agents right on a phone. An independent benchmark house measured it as the leading open-weight model at that size, top of its class by more than 7 points. Native tool calling is the quiet headline there. It means the little model doesn't just chat. It can decide on its own to call a calculator, search your files, or hit an outside service. That's the difference between a toy and an engine. Exhibit 3 is the wild one, and the one to hold at arm's length. A startup claims a new attention design that scales almost in a straight line instead of exploding, letting a model handle a 12 million token context using, they say, up to 1,000 times less attention compute. If that holds up, it rewrites the cost of long context entirely. Notice the pattern. This isn't one lab, one fluke, one lucky benchmark. It's 4 independent breakouts in a matter of weeks, all pointing the same direction. Small, local, cheap, suddenly punching way above its weight. When the whole niche moves at once, something real is happening underneath. The question is what? Now the cold water, because the gap between that leaderboard and real life is wide. Topping a benchmark and being useful are 2 different sports, and the tiny models are much better at the first one. Go read the comments under any of these breakout videos. The people who actually downloaded the thing, and the same notes keep coming up. It nails the one narrow task it was tuned for, then falls apart the moment you push sideways. It gets caught in loops, repeating itself. One person watched a tiny model start a normal English conversation and drift into replying in Chinese within 3 messages. These are not the failure modes of a giant. There's a reason for that, and it's baked into the size. A 1 billion parameter model physically cannot hold that much knowledge. Squeeze the parameters down and something has to give. Usually the broad encyclopedic memory that makes a big model feel like it knows everything. So a tiny model can out-reason a giant on a clean math problem and still confidently invent a fact about the real world, because it simply never had room to store it. And then there's the claim to be most careful with, the 1,000 times less compute one. Right now that number comes from the company selling it, not from an outside lab that reproduced it. Serious researchers have publicly asked for exactly that, independent proof. It might be real. It might be a best-case demo. Until someone outside the building replicates it, treat the headline as a promise, not a fact. Here's the moment that cuts through all of it. During a national internet shutdown, one person reached for a local offline model. The exact situation these tools are supposed to own. No cloud, no connection, just them and the model on the device. And the verdict? Not that useful yet. That's the honest state of play. The dream is right. The delivery isn't there, yet. So if the tiny models are half broken on their own, why is everyone who works in this field paying such close attention? Because they were never supposed to work on their own. And this is the idea that makes the whole picture snap into focus. One of the most respected voices in AI floated a concept he calls the cognitive core. The pitch? Stop trying to cram the entire internet into a model's weights. Instead, build a small model, a few billion parameters, that deliberately trades away encyclopedic knowledge for raw capability. It doesn't memorize the world. It's good at thinking, following instructions, and using tools. Picture the difference between two kinds of smart people. One has memorized an encyclopedia. The other doesn't know every fact, but knows exactly how to reason, which tool to grab, and where to look things up. The cognitive core is the second person. Small, sharp, and unafraid to say, "Let me check." And this is the part everyone skips when they quote the idea. The same person who described the cognitive core said, in the same breath, that it should delegate and double-check the hard parts with cloud models when the internet is available. Read that again. The vision was never tiny instead of giant. From the very start, it was tiny that knows when to call the giant. That reframes every one of those benchmark wins. A 1 billion parameter model beating a giant at math isn't a sign the giant is obsolete. It's a sign that the thinking part, the reasoning core, can be shrunk down small enough to live on your device, run offline, and cost nothing. The knowledge part and the hardest reasoning can stay in the cloud, called only when it's actually needed. Which brings us to the thing you can actually build. Let's make this concrete because hybrid stack is easy to say and easy to handwave. Watch one actually run. Say you ask an assistant on your phone, "Go through my inbox, find the invoices I haven't been paid for, and draft a polite reminder for each." No internet in this example. You're on a plane. Step 1. Understand the request. That's pure reasoning. Break the instruction into parts. The local 1 billion core handles it instantly, on the device, for free. Step 2. It needs your emails. It doesn't know them. It was never trained on your inbox. So it does the thing native tool calling unlocks. It calls a search tool right there on the phone, pulls the messages, and filters for the unpaid ones. Still local, still offline, still free. Step 3. Draft the reminders. Simple, templated writing. The little model is fine at it. It formats the list, fills in the amounts, writes a clean first pass. And for most of that job, parsing, searching, filtering, drafting, the tiny core did the whole thing on hardware in your pocket. That's the 80%. Now the 20%. One of those emails is a mess, a delicate client relationship, a legal nuance, a tone you cannot get wrong. The little model can feel itself reaching the edge of what it's good at. So instead of bluffing, it does the smart thing. It flags that one message and, the next time you have a signal, routes just that single hard request up to a frontier model in the cloud. One expensive call for the one part that earned it. That's the whole idea in one workflow. A cheap, local, always-on core does the bulk of the labor and knows its limits. A powerful, costly model in the cloud gets pinged only for the genuinely hard slice. Most of the work never leaves your device, never touches a bill, never needs a connection. The hard part gets the big gun. That's the hybrid stack, and it's not a prediction. The pieces to build it shipped over the last few weeks. Now the catch, and it's the one that separates a real take from a hype reel. That routing decision, is this the easy 80 or the hard 20, is itself hard. Get it wrong in one direction and you send everything to the cloud, and you've just rebuilt the expensive thing you were trying to escape. Get it wrong the other way, and the little model confidently botches a job it should have handed off. The sharpest comment in this entire wave said it in one line. These tiny models are at their best as a sub-agent, sitting behind a router and a frontier model. Not the star, the cheap, fast worker on a team, with a smart dispatcher deciding what it handles and what gets escalated. That dispatcher, the router, is the actual hard engineering, and it's the part almost none of the hype talks about. So be honest about where this is. The tiny models are real and genuinely good at a narrow band of work. The cognitive core idea is sound, but the glue that turns a swarm of small models plus a cloud giant into something that feels seamless, that glue is early, and it's fiddly, and today you mostly have to build it yourself. The parts are on the table. The assembled machine, for most people, is not a download. It's a project. So should the cloud giants actually be nervous? A little, but not the way the thumbnails think. Nobody's frontier model is getting replaced by a 1 billion parameter model on a phone. The hardest reasoning, the deepest knowledge, the biggest jobs, those stay in the data center for a long time yet. The pressure is quieter and more interesting than the mainframe is dead. It's that the cheap, high-volume 80%, the tool calls, the quick drafts, the routine parsing that a huge amount of AI usage actually is, that work is sliding toward models that run local, offline, and free. And every task that moves onto your device is a task the cloud no longer gets paid for. That's the real shift, not tiny beats giant. It's that the map is getting redrawn. The everyday, easy-to-verify work drifting to the edge, onto your own hardware, while the frontier keeps the hard, rare, high-stakes calls. The giants don't lose the war. They lose the low-margin middle, one routine task at a time. And for you, the person deciding what to build or what to trust, the takeaway isn't download a tiny model and cancel your subscription. It's the opposite of picking a side. The winning move is the stack that uses both. So let's bring it home. 4 things to actually remember. 1. The tiny model wave is real. A 1.5 billion model really did beat a reasoning giant over 400 times its size on hard math. And it's not alone. Small models are doing things small models weren't supposed to do. 2. The benchmarks oversell it. In real use, these models are narrow, they hallucinate outside their lane, they get stuck in loops, and the flashiest efficiency numbers are still waiting on independent proof. A leaderboard win is not a working tool. 3. The idea that reconciles the two is the cognitive core, a small, sharp reasoner that lives on your device and, crucially, knows when to call the cloud. It was never tiny versus giant. It was designed as tiny that delegates to giant. 4. So the thing to build, and the honest verdict, is the hybrid stack. A cheap local core doing the routine 80%, escalating the hard 20% to a frontier model, with a router in the middle doing the real work. That router is early, and mostly still a do-it-yourself job, but that's the direction the whole field just tilted. The one-line verdict? It's not tiny versus giant, it's tiny and giant, and the people who figure out the handoff win. Everyone still arguing about which one wins is watching the wrong fight. The frontier isn't collapsing into your pocket, and it isn't staying locked in the cloud either. It's splitting in two, and the seam between them is where the next stretch of AI actually gets built. That's the loop. We'll keep reading past the thumbnail so you don't have to. Stay in the loop.